Welcome back to our next video on Practice Problem Chapter 7. So here we have, where's our paragraph? Our BMI of patients recently enrolled in a study, and we need to calculate BMI given feet and inches and weight. Once again, this is all just practice for conversions. Going forward, the more you practice them, the better you become. BMI is kind of, I would say, I don't want to call it classic, but one that you can definitely encounter very often because we have to convert our feet to inches and our inches to centimeters, centimeters to meters, and then we want to take our pounds and convert it to kilograms. So we're moving forward. So I kind of showed participant A here what the value should be, and I'm just going to write what the BMI is on the side here for the rest of these individuals. Now you should get an answer very similar to these. If you're not, double check to make sure and see how many decimals you're going out. I once again normally go about 4 decimals out, and make sure you're not rounding in the middle of a problem. If you're rounding in the middle of a problem, you're going to probably get very different answers. Other things we were given in this problem is n is equal to 6. When you have your new whole BMI set, you're going to get your x bar, your average of your BMI. Remember, use technology, use things around you, be able to calculate your standard deviation here. Remember, since we're given a sample, we're calculating the standard deviation of the sample here. Of this sample, it's going to be 7.349. So make sure you use technology to help you get some of the answers that you're looking for. Part A, we're going to be constructing a 95% confidence interval. So our confidence interval, x bar plus or minus e, just like we've done in the previous video. So I'm going to just kind of write this out. Since we know it's 95%, our x bar is 27.866 plus or minus 1.96. That's going to be our z of alpha over 2 times our standard error of x, 6.708 divided by the square root of 6. Write all this out again. 1.96 times 2.738, 27.866 plus or minus these values, and you're going to get a confidence interval of, well, I'm going to write this value here for you, 5.366. When you plus or minus this value here, you're going to get the confidence interval that you can say is 22.5 to 33.232. Correctly interpret the confidence interval. I'm going to rewrite that after it, but just like we have been doing, you're going to want to say that we are 95% confident that the interval from 22.5 to 33.232 actually does contain the true value of mu, as you can see in the answer key. But I'm going to move this along. I did the other one. I forgot to write that one before I started the video. I'm not going to waste time watching you write a sentence out. Next one, we're giving patient's age, and we're trying to also calculate here a 99% confidence interval. So what do we know? Our n equals 7, x bar is equal to 60. Our standard deviation given to us here is 5.9. So we're going to calculate a 99% confidence interval, and that's going to be 60. 60 plus or minus a value we should know for z, 2.575. It's also outlined in the book under the confidence intervals, times our standard deviation over the square root of n. When we write all this out, we're going to get 60 plus or minus 5.7396, giving us a confidence interval of 54.2604 to 65.7396. Do the same thing using a 90% confidence interval. Once again, use the values that are given to you already. So we know at this value should be 1.645, and we know the standard error is going to be 2.229 calculated from above. 60 plus minus 3.666, you're going to get 56.334 to 60. 3.666. So you can notice the difference between the two. When you're 99% accurate, your net is bigger, right? You're more likely to catch more values than at 90% confident. Your net's kind of be a little smaller in nature because you're only 90% confident that it's between here. 99% confident the values are going to be bigger. So as you increase your confidence, your interval is going to get wider. As you decrease your confidence, that kind of net gets a little bit more narrower because you're not as accurate as you can be. 14 here, we're going to be using a sample size. So right here is variant how many newborns are needed to sample in order to be 95% confident. Our equation is going to be n of what I like to be z of 1 minus alpha over 2 standard deviation over the margin of error squared. Plug our values in. We're going to be 95% confident. That's a z of 1.96. Our standard deviation of 7.46 divided by the margin of error of 6.46. Plug in our values, square it. You're going to get, let me write this one, 2.2632, everything in the parentheses, squared, which is equal to 5.1220. Now remember, we always want to round these up to the nearest whole number, so we're going to want to say we want 6 newborns. Once again, we're doing another sample size. How many children should be sampled to attain 95% confidence? Since we use 95% confidence again, it's going to be 1.96 times our standard deviation of 4.87 divided by margin of error 4, all squared. You're going to get a value of 2.3863 squared, which is equal to 5.6944. Once again, we want to round this up to a value of 6 children needed. Always want to go up in values when we're doing sample size. Next one here. So as you can see, I already have that one written like I told you I did, but let's go through it. You have CD4 count in patients. One thing to keep in mind here is there's 3 columns here. You can see patients A through R. So there's a huge sample here. We have a value of n equals 18. We're given a standard deviation of 24. And what we're not given that we have to calculate is our x bar. So we have to add up all these CD4 cell count values, add them up together, divide by the total number of 18, and you're going to get a value of 305.5. Since we're given all that, we can now calculate our 95% confidence interval. So that's going to be 305.5 plus or minus 95%. Something just to hammer home, it's going to be 1.96 times the margin of error, which is going to be 24 divided by the square root of 18. When you work all this out, you're going to get a value of 305.5 plus or minus 11.0873. Gives us our confidence interval of 294.4127 to 316.583, and that's at 95%. When we interpret it, you want to say that we are 95% confident the interval from 294.4127 to 316.583 actually does contain the true value of mu. So once again, doing kind of the same things over and over. More practice, the better. If you have questions or something doesn't make sense, always please get in touch with me, and I will be more than happy to help you out. All right, that will conclude this video. Have a great day.